Today I'm here to talk about the plastic brain. That's a short form for the neuroplastic brain, which is a very, very exciting, inspiring, and hopeful series of discoveries that I believe is going to transform our world. It's the most important change in our understanding of the human brain in 400 years. And since most of us think that all thought emerges in some way from the brain as the control center for the nervous system, and therefore all human activities emerge from the brain, any fundamental change in our understanding of the brain has always led to fundamental changes in our understanding of all human activities. Now, as a simple definition of neuroplasticity, I prefer the following one. It's just that property of the brain that allows it to change its structure and its function. Change its structure and its function as it goes along. That means as it responds to the environment, as we imagine things, as we and think, which is quite extraordinary, and as we act and do things. And neuroplasticity is a property which is existing, the where of neuroplasticity is a property that is existing at all levels of the brain. It exists at the molecular level. It exists at the level of the genes. It exists between cells and their connections. It exists between clumps of cells or the larger departments of the brain. And even our behaviors, our behavioral plasticity, our ability to change our behaviors is a function, in fact, of neuroplasticity. You know, the most extraordinary neuroplastic discovery, as far as I'm concerned, is a product of a series of brilliant experiments by Eric Kandel, which ultimately showed that our thoughts, and even things that ultimately we imagine, basically get under the skin, if you will, of our DNA and can turn certain genes on and certain genes off and lead to the alteration of the structure of the neurons or the nerve cells in the brain, so that when people are imagining, they are changing the structure and function of their brains. Now, I've said it has general applications for everything, every human activity, but some obvious ones are medicine and medical treatments, neurological treatments, psychiatry, psychology. But it goes beyond that. I mean, insofar as even nature is seen to have emerged from the brain, if the brain is fixed, there have to be very particular limits on human nature. This has been somewhat expanded by understanding of neuroplasticity, and I can go into this towards the end of the talk. I'm not saying that neuroplasticity is about infinite change or infinite malleability, because it's not. But there are areas that we thought we couldn't change, which clearly we can. Neuroplasticity has to revise our understanding of love. We now know that when people fall in love, their brains are molded by those whom they love. They're molded in quite a profound way. Love is a particularly malleable state. Sexual attraction has to be revisited. We can acquire sexual tastes and types in the course of our development, and biologists tended to describe the human sexual desire as something that was, particularly gluttonous and indiscriminate. But as I've looked at it, and as a psychiatrist and analyst worked with people, I've found that, alas, the human sexual libido is particularly finicky, if you really look at it very carefully. And neuroplasticity helps to explain how that's come about. The whole process of acculturation and being immersed in a brand new culture, the immigrant's experience, is really so difficult because immigration turns out to be an extraordinary brain workout where the human brain is having to rewire itself in the process of learning new ways of thinking and perceiving, literally rewire itself. The plasticity revolution helps us to understand the influence of technology upon us, and we'll talk about that a little bit later on. Education has to be revised as we understand that it's not just about content and skill acquisition, but remodeling the brain. Politics, the psychotherapies, business, any kind of training, anything that involves performance, dance, sports, the military, are all going to have to be reconceptualized in light of this revolution, which gives us hope. But as you'll see, the way I describe the neuroplastic brain, it's a more resilient brain and a more vulnerable brain at the same time, because as long as the brain was thought to be something which couldn't change, there was arguably a kind of stability to its properties, which is now lost to us because it's so easily influenced by the environment. To investigate neuroplasticity, I did a lot of research and a lot of reading, and I visited people who I managed to find who had already undergone neuroplastic transformations. I call the people who changed the human brain neuroplasticians, and the transformations and kinds of things that I was able to describe in detail in the book included a woman who was born with half a brain that rewired itself, another woman who had extraordinary mental deficiencies who went on to cure her own deficits and cure those of others, blind people learning to see, stories of incurable strokes and learning disorders altered, intractable pain erased, children with cerebral palsy learning to move more gracefully, and in my own work, working with people with entrenched anxiety and depression and character issues that had been in place often for 30, 40, 50 years, and seeing that they too could change, even into old age, because we now know that neuroplasticity exists from cradle to grave. Now, why is this important in terms of being revolutionary? It's important because our best and brightest minds in neuroscience, a very great consensus, believed for about 400 years that the brain was best thought of as like a machine, machine-like. And this is still with us whenever we read a newspaper and we're told that this or that mental function is hardwired, or we think of the brain as though it were a computer and then slip into forgetting that that's just a temporary metaphor. So the human brain was seen as like a machine with parts, and each part performed a single mental function. And that belief eventually got enshrined as localizationism. That was the term for it. And it gave rise to what I call a neurological nihilism, because it meant that if you were born with a kind of a brain deficit, let's say you had a severe learning disorder, or you were born with a chunk of your brain missing, which happens from time to time, it meant by definition there was nothing that you could do about it. And all of our treatments for learning disorders, in fact, were called compensations. They meant that the mature person with a learning disorder learns to work around the learning disorder. And sometimes compensations helped. But if you had a lot of learning disorders, you often didn't have shall we say, the cortical real estate or the wherewithal to find ways to work around. Now, students who were slow in processing speech in lectures were encouraged, for instance, to tape the lectures or to get someone else to take notes for those. And that seemed to be the best that we could do. Now, we've since learned that this plastic brain is a use it or lose it brain, and that if you don't use something, it wastes away. So that, in effect, condemned those students to cause any facility they might have had in that area to wither away. That was one of the problems with this approach. But the neurological nihilism extended to people who had fairly healthy brains, who sustained a certain kind of brain trauma or a stroke later in life. And it meant really that there was nothing much we could do about that. And we watched people for about 6 weeks. And at the end of that 6 weeks, we assumed that they would be the best that they could be after that. We didn't believe that the brain could grow any new cells. Many of our organs can and have stem cells within. But the best neuroscientist alive 100 years ago spent over 10 years looking for those cells, and he simply couldn't find them, and nor could anyone else till very recently. There were other implications of neurological nihilism. One of them had to do with the second half of life. If the brain's like a machine, machines change, they wear out, through wear and tear. And our basic expectation for our brains would be that they would wear out, and that mental exercise or some kind of brain exercise really was unwarranted. It wasn't a serious activity. It wasn't really going to offset the damage that time would do to us. Now, it turns out that all of this is actually spectacularly wrong. And we miss the fact that our brains are plastic. And a serious person has to ask, if the brain is plastic, how is it possible that we missed it? And there are four basic reasons we missed it. And the first reason is very easy to understand. It's a technological reason. To see plasticity, you have to be able to make microscopic movies in one way or another, a series of pictures of the human brain while it's functioning. And we simply didn't have that capacity. Certainly till around 1950, when we began to have certain techniques to take this. And even into the 60s and 70s, most of the techniques we had of taking shots of the brain were not microscopic, or they were snapshots. The second reason is the most important reason, which is what I call the mechanistic bias. And this is actually very, very interesting. You know, mankind has had three major views of nature in history. The first view of nature, in principle, wasn't opposed to the notion of neuroplasticity, and it was the view of the ancient Greeks. Now, the ancient Greeks invented our concept of nature. Physis, the word that they used for physics, was the word for nature. And often the originators of concepts see things most clearly. And for the ancient Greeks, all of nature was one vast living organism. Things that we don't think of as living, they thought of it as living. And they believed that all things, insofar as they took up space, were made of matter. And of course, they had some insights or some thoughts about atoms, and so that they share with us. They believed that all things, insofar as they were orderly, partook of intelligence in some way, broadly understood. A very, very important difference between themselves and those who came after. And that all things, insofar as they moved, were alive. The Romans, who inherited the Greek view, for instance, saw the planets in an anthropomorphic way, and they used it's Jupiter, Mercury, Mars are names of gods. That's just a residue of this idea of seeing nature writ large as alive. Now, this wasn't a perfect view of nature. It gave rise to a very mystical and arguably overly animated universe. And combined with the Judeo-Christian tradition of a created universe, gave rise to something that in some ways was so mysterious that we didn't even want to begin to try to explain that. The second great view of nature, the one which most of us have one foot in this second great view of nature that I'm going to describe, is that of all nature as one large mechanism. And Galileo was arguably the most important figure here, and he showed that the planets are inanimate, but the reason that they move is they're moved about by these forces which were described ultimately as having to do with the mechanical laws of physics. Mechanical has to do with motion, and the people following Galileo were so impressed that soon many scientists and intellectuals described all nature as a cosmic clock and drew pictures of the planetary orbits as like a very large clock. And they soon began to think that for any explanation to be scientific, it had to be mechanistic. And that meant that all science was being reconceived mechanistically, including biology. And the first great discovery of mechanistic biology was absolutely wonderful. It was William Harvey's depiction of the circulation of the blood in our vessels, the vessels like pipes, the heart a pump, the pump a machine, of course. The next great accomplishment was that of Descartes, who, inspired by Galileo and Harvey, tried to explain the functioning of the nervous system. And in a very famous diagram, he shows a picture of a man with his foot on a fire who's sensing something which is disruptive, and currents are going up vessels. His nerves are like vessels. They're passing up to his brain, and they bounce back, they reflect back, and cause the man to move his leg away. This idea of the reflection of the movement gave rise to the modern concept of reflex, which was eventually seen by many thinkers as the basis of the nervous system, a series of reflexes, mechanical, not that much unlike the picture of the heart and its vessels. And this was the beginning, a very brilliant and important beginning, of trying to look at the brain in terms of parts, and it gave rise to localizationism. Now, localizationism is something that is very familiar. You see it in your newspapers every time you open up the science section, if you're lucky enough to have one, and there's a colored picture of the brain and an arrow that says this is where your brain does this, listens to music, this is where all the bad thoughts come from, the good thoughts come from, this is where you learn to read, and so on and so forth. And localizationism ultimately became the greatest accomplishment of 19th century and earliest 20th century science. Now, the Cartesian view and this view of a mechanical biology had critics from the very beginning. And one of the most important ones was Jean-Jacques Rousseau. And he made some very simple observations. Now, Rousseau was a man who was deeply immersed in the classics, therefore deeply immersed in the Greek point of view. And he observed that the mechanical view of nature didn't do very well at distinguishing between things living and dead, animate and inanimate, which is, for sure, many people have observed that the foundation of modern science and the introduction of the cosmic clock and the Galilean approach led to a progressive disenchantment of the world around us. Everything was matter in motion, very, very different from the created world of the Bible or the world of the ancient Greeks. And all of us, to a degree, carry the burden of living in a world where science depicts even living things in some ways as mechanistically. So if you're excited by the notion of neuroplasticity, in part it's because it has to do with a re-enchantment of your brain from a hardwired system and with an operating system and so on and so forth to something that is alive in a new way. Now, Rousseau got his insights because he was actually part of the third great wave of nature, the third great way of viewing nature. And that is the notion that nature is a historical process, meaning it's changing. And that began because around Rousseau's time, there were great naturalists like Buffon and discovery of fossils. And scientists began to realize that the species that were on the planet at the time were not the only types of species that ever existed. They were not immutable. Somehow or other, this thing that was thought never to change, the forms of birds and bears and so on, actually was changing. And there were rudimentary ideas long before Darwin that something is evolving in nature. And this notion of nature as having a historical process began to be the other foot. So we have 2 feet. We have a foot in 2 great views of nature, the mechanistic view and nature as process. Now, shortly after Rousseau's death, a man named Charles Bonnet, who read Rousseau's works, and we know he read them because he did everything in his later years to have them banned, burned and banned for political reasons. But he himself was a great biologist, and he took certain ideas that Rousseau had articulated in the Emile. Now, the Emile is the first book ever written on child development in any great detail, and it's a very, very great book. And one of the things that Rousseau said in the Emile is that we can develop our senses as though they were muscles. Rousseau may well have gotten that from Plato. In other words, that earlier view of nature, because in Plato's Republic, Socrates says at a certain point, thinking, rationality can actually be developed the way a gymnast in the gymnasium or someone who's practicing to develop his muscles can develop. Now, the Greeks hadn't quite clarified. There was a big argument as to whether the organ of cognition was the brain or the heart. But because they fundamentally weren't opposed to the notion of plasticity, that's right there in Plato, and educated people always knew about Plato. So there was an undercurrent that he embraced. So Charles Bonnet basically wrote to an Italian experimental scientist named Malacarne, saying, could you develop some kind of experiment to test whether somehow or other cognition can't be trained and developed in the brain? And he did that with he got groups of animals that came from the same litter, and he was an expert in the cerebellum, which is a part of the brain at the back of the brain that has to do a lot with movement. And he gave the first group intensive kinds of exercise, training, and stimulation. The second group, just the normal kind of rearing. And at the end of it, he sacrificed both groups of animals, and he found that the cerebellum had actually enlarged itself in the group that had received training. Now, this experiment went against the paradigm, and it was basically lost in the literature. But hundreds of years later, this is one of the core ways we demonstrate neuroplasticity. So all that has been about the second reason we miss plasticity. There was just a mechanistic model that just couldn't have a way of explaining it. The third reason that we miss plasticity, because remember, it's always been there, has to do with a halo effect or a negative halo effect of the mechanistic model. And that is, when people did get better from strokes, which happened from time to time, they were ignored. It was explained away, and it was explained away in the following way. There was a notion that the brain after a stroke goes through a kind of brain shock, just as people after a spinal injury go into a kind of spinal shock. There was a fancy medical term for that. When someone actually started to get better, scientists said there couldn't really have been damage in the brain because of that stroke, because that person got better. Their brain was in shock, and then they gradually came out of it. And that shock meant that there were chemical disruptions and blood flow alterations that made it unable to function. The final reason that we miss the plastic brain is what I'm going to explain at the end of this talk, because I have to tell you some other things first. Now, in my travels to meet the neuroplasticians and bring together people who are working in many, many different areas, and often not even talking to each other, because they were all, in some ways, many of them were doing these activities on the sly. There was something furtive about neuroplastic investigations. All the people that I label as neuroplasticians actually were at one time or another thought to have been heretical or foolish or squandering their careers, and many of the experiments that they did were in fact not something that they got a grant for, but they were doing on their own time. But one of the most remarkable people I met was Dr. Paul Bach-y-Rita, who recently has passed away. And he had such an extraordinary personal story, I just want to tell it to you. Paul was the kind of guy who was a very, very wide reader. And he was interested in philosophy and literature, and really had no interest in going to medical school till one of his father's friends who said something effective, well, you know, why not try to, no, don't try to go to medical school, you'll never get in. And on that kind of dare, Paul, a very foolish way to live your life, by the way, Paul Bach-y-Rita decided to go to medical school. And he got in, and he was a fairly conventional doctor, but he also started to develop research interests. And he began to leave that aside, and he worked with a Nobel Prize winner, and he became a world expert on the movements of the eye and many other areas. And he was a kind of a polyglot, and he spoke many languages and traveled in many places. His younger brother, George, was in medical school when he got a call telling them that their father, Pedro Bach-y-Rita, who was a Catalan poet who was now teaching in New York, had had a devastating stroke. And 6 weeks, George was in medical school in Mexico at the time, and 6 weeks had elapsed, and Pedro got the usual amount of training, rehabilitation training, and he couldn't move and he couldn't speak. The doctor called him and said, look, George, you've got to come and arrange for your father to go into some kind of chronic care facility. He is never going to be independent. There were several things going on here. First of all, Pedro Bach-y-Rita was a very, very adamant, willful person who couldn't stand the idea of being dependent. And George, to his credit, knew absolutely nothing about rehabilitation and had no preconceived notions. And so what he did is he actually took his father down to Mexico. And he looked at him and he said, Papa, you learned how to walk, because he couldn't move his limbs, as a baby by crawling. So we're going to get you to crawl. And he got his father down on his all fours and got him to crawl. Then later he took him outside to be beside the retaining wall of this villa that these medical students shared, and he got him to put one arm for support up against the wall. after he developed the ability to do that, they gradually and progressively introduced more and more activity for the different limbs, and they got him to a point where he actually could walk and move, and then he taught himself to write again, and again, same incremental way. He was able at a certain point, because of the crawling exercises, to raise his hand and just drop the entire arm onto the typewriter. And then he got to the point where he could drop a wrist and then individual fingers, and he taught himself to type, and he taught himself to write. At this point, he was in his late 60s, and he actually went back to teaching, and he got married. He became quite active. And actually, that's not the interesting part of the story. The interesting part of the story is what follows, and that is, when he was now in his mid-70s, he was mountain climbing with friends in Bogota, Colombia. And he had a heart attack. It was a fatal heart attack, and he died very shortly thereafter. And at that point, Paul was working in San Francisco as a physician, and he asked them to send the body back to San Francisco, and he ordered an autopsy to find out what had happened. It was just a fairly routine thing for doctors to do. We didn't have very many brain scans and other ways of determining what caused people to die, and it was an incredible way to learn about things. And a couple of days later, Paul got a call from the pathologist to come down to the lab. She wanted to show him something very important. And then he came there, and then he sat down, and then she spread out in front of him a number of slides, and these were slides of his father's brain. And he was numb and almost in shock and revolted, but he could see that she was very excited about something. And what he saw when he looked at those slides was that in the stroke, he had blown out 97% of tracks that had to do with movement, the movement parts of the brain and parts of the brain that conducted those signals to the body. And that devastation was still there. He had not had a trivial stroke. He had actually had a massive stroke. And what that meant was that the work that George had done with his father, Pedro, had somehow reorganized parts of the brain, presumably adjacent to the lesion. And this had to mean that the brain was plastic. Now, Paul went on to do many very, very extraordinary experiments, and of his generation, he was the first to really get a sense of what I believe what plasticity meant. He pioneered work in strokes and late plasticity, he called it, at the time, and he became very, very interested in what's called sensory plasticity. And I went to visit Paul at a time that he was treating a woman named Cheryl Schultz. Now, Cheryl had a just nightmarish disorder. What Cheryl had was no functioning balance system whatsoever. She'd had a routine hysterectomy and was given a medication which can, on occasion, cause the vestibular apparatus, the part of your ear which is the sensory organ for balance, to basically be destroyed. And we have senses that we don't know we have. The sense of balance is something that, for instance, Aristotle didn't describe among the five senses. But our whole sense, when we talk about being grounded, right, or feeling rooted or stable, is probably some kind of poetic description of what it is like to have a functioning balance system. We need maps. We need to know where we are. In fact, part of our definition of ourself is, we are here, right? She had none of that, so she felt like she was perpetually falling. The people who have had this rare side effect call themselves wobblers, and many wobblers commit suicide. So because Cheryl felt she was perpetually falling, I had to ask her this question, which is, okay, Cheryl, what happens when you've now fallen to the floor and you're on the floor? Do you still feel like you're falling? Or do you get some relief? And she said, I feel like a trap door opens in the floor and I keep falling. But when I came to visit Paul, he was using a new device on her. Because he believed that the brain was plastic, he would believe that there would be ways you could reroute information to the brain. And he created this device which had something like it looked like a stick of gum, except it had about 100 little electrodes on it. And you'd put it on your tongue, and it would be a very, very low voltage. And it was rigged to a computer, and you also wore a hat that had something like a gyroscope or an accelerometer in it. So when you tilted forward, the gyroscope would say you're going forward. When you tilted back, it would tell you you're going back. It sends signals to the computer, which would then do a readout onto the stick of gum on your tongue. And so I put on the hat, and I bent forward, and I felt these champagne bubble-like sensations going forward and back. They went backwards and to the side, etc. So Cheryl basically put on the hat. And you know, she's a person who was like completely disabled and had to be sort of held and escorted around, or if she walked into a room, she'd have to have her back against the wall, and she'd have to have her eyes open all the time to help her just see straight lines so she wouldn't fall over. She put this thing on, and she was just almost within, I don't know, 30 seconds, a sense of calm over this very, very distressed face could be seen. And she just stood there, and it seemed like she was in bliss because the sense of falling had finally stopped. And it was quite extraordinary, and what it meant was somehow or other, information that was being fed to the sense of touch, which was on the tongue, was somehow or other by the brain being rerouted to those neurons that would process balance so that she would get a certain degree of relief. And so after about a minute of just wearing the hat, she started to lift her, you know, one hand and then the other off of the table and move around a little bit. And you could see that her balance was actually perfect. And again, that's not the interesting part of the story. The interesting part of the story is the following. After 20 minutes, she took the hat off, and she was just fine. And she went over to Paul Bach-y-Rita, and she gave him a kiss. She came over to me. She gave me a hug. Then I'm writing frantically, and then I look up, and she and Paul Bach-y-Rita are dancing, and she leads. And then she starts to do various antics, and we go outside, and there's a parking lot, and there's that little bit of elevated concrete that's like a kind of a curb, and she walks one foot in front of the other. This woman who before that had to walk with a very, very wide gait, otherwise she would fall over. And over the next year, she would wear the hat, and each time she wore the hat, progressively her ability to just be oriented in space and not fall over extended in time, till she got to the point where she doesn't wear the hat at all, and she is actually normal now, and her brain has rewired itself. And she no longer calls herself a wobbler. She has since gone in to become do rehabilitation herself, a very extraordinary experiment with implications, many, many implications. Paul Bach-y-Rita then developed a device to help blind people who had been congenitally blind since birth, learn how to see. A similar device, there'd be a camera attached to a computer that would give input to an array of electrodes, which could be then put up against the back or ultimately the tongue. And people who had never seen anything over time and with training could learn how to read. They could spot, they could say that this is a model, this is her name, this is a telephone in front of a vase. If you hurled something at them, they would duck. They could detect a looming object in perspective. So this work has since been studied in Canada, and we've found that, in fact, even though the input comes in the tongue, it's processed in the back of the brain in what has been called the visual cortex. So there are many, many extraordinary reorganizations of our senses that are in fact possible. Another really important story, again about a stroke, was the story of Michael Bernstein. He was in his mid-50s. He was a doctor. He had done a lot of microsurgery that day, and then went to play tennis, and then started to feel that he couldn't move properly, and he as well had a stroke in one half of his body. And he went because Edward Taub had a neuroplastician had a clinic nearby and was just starting a new treatment. Michael Bernstein went for that treatment, and basically, again, it was incremental training, but what Taub did was the following. When people have a stroke, again, as I said, people have a kind of a brain shock, and so they can't move the affected limb, and they try to move the affected limb, and it doesn't work, and then they learn it doesn't work, and that's a kind of learned helplessness. That gets wired into the brain, so they start to use their good limb. Now, because it's a use it or lose it brain, we've shown that in hundreds and hundreds of experiments. What do you think happens? Well, after the brain shock passes, if there is any residual capacity for that arm, it's not being activated, and so you lose it, and the good arm gets better. So his genius was very simple. And by the way, many of these interventions are very low-tech and simple. Was to take the good arm and put it into a sling or a cast so the person couldn't use it, and then give them incremental training. Now, I'm telling you this story, it's very much like the Bach-y-Rita story, but just to think about these issues. Brain plasticity is a very competitive phenomenon. We know from many experiments that there's a competition inside the head for cortical real estate, for processors. And so if you're not using, for instance, your right hand, the motor cortex, the thin outer layer of the brain that processes movement for the right hand, will probably be taken over by something which is going to make use of that. You sort of think of that very keen, annoying kid in your public school class who always puts his hand up first and always wants to take every question. That's what a neural network is like. So the routines that you develop are the ones that you're going to tend to default to very quickly. And there's a kind of competitiveness there. And that turns out to be, in fact, very, very problematic. See, because the brain is always like that. That's one of the reasons we develop habits so easily. The brain is a very habit-forming thing. You should be very careful about your brains. And it becomes very, very difficult to shake negative habits. And what Taub was doing was basically kind of defining the use of the good arm as like a negative habit and creating a block for it so it couldn't basically get there. This is Toronto, and Toronto has one of the most important neuroplasticians alive, and that's Barbara Arrowsmith. Barbara Arrowsmith was this woman who was born with so many cognitive deficits that people simply did not know what to do with her. But the brain is a very eccentric thing, and she had some areas of great strength. We've known for a long time that people who have weaknesses in some areas can be extraordinarily strong in other areas, and she had a brilliant memory in many respects, and she was very good at observing children. Somehow or other she got through high school just by using her memory, and actually got into OISE. She couldn't believe it when she got in, but people found that she was very, very good at observing children. But she was absolutely devastated by some of the following problems. She couldn't relate symbols, which is something the brain does all the time. So if she had to look at a watch, she couldn't really sort out the time. She couldn't relate the small hand and the big hand. And she was also dyslexic. And when she had to listen to people talking, she couldn't sort out what they were saying using all of these symbols in real time. So she had to go over things 4, 5, 6, 7, 8 times, simple conversations, till she would finally get it. And she felt she didn't live in real time, and everything around her was like a fog. She couldn't really appreciate meaning. Now, she had many, many other learning disorders as well. She had problems reading. Her eye span wasn't normal. She had problems pronouncing words. A part of the brain that is involved in motor speech wasn't working properly. But she was absolutely overwhelmed by all of this. And when she was trying to use compensations but couldn't because she had so many difficulties. And when she was 28, she was dating a man named Joshua Cohen. And he had discovered the work of the great Russian neuropsychologist Alexander Luria, who had written a book, The Man with a Shattered World. And it was about a Russian soldier who had got shrapnel in his head when fighting the Nazis. And he described the same difficulties she had. One of the difficulties she had, for instance, with symbols was because she couldn't understand relationships, she couldn't understand prepositions. They're all about relationships, between, on, among, and so on and so forth. And right in his diary, he said, I can understand that if I read an elephant is bigger than a fly, I can understand that an elephant is big and a fly is small, but I have no idea what it means to say an elephant is bigger than a fly. And he described not being able to live in real time and having to try to process things after. He couldn't understand read a wristwatch anymore. So in some ways she was elated because she realized she wasn't crazy. So many kids with learning disorders think there's something wrong with them, and because we have a very simplified understanding of cognition, we tend to think that they're lazy or not working hard. We sense some of them are bright, but they just don't accomplish things. So she still felt in absolute despair. And then she came across one other paper by Mark Rosenzweig, and it was a description, might sound a little bit familiar, of an experiment he did with rats, where he took two groups of rats and he put one of them in an enriched environment and one of them in a normal sort of cage, and stimulated them for the enriched ones for a period of time, then sacrificed the animals, and then looked at their brains. And lo and behold, he found that the brains of those raised in the enriched environment had, and then he described it in more updated terms, more neurochemicals there, more supporting cells, a better blood supply, heavier weight, larger. And she realized, my goodness, maybe exercise will work. So she took one of her signature difficulties, which was reading a watch, and got Joshua Cohen to write out, the hour, 2 o'clock, 3 o'clock, 4 o'clock, then added a minute hand and just kept turning them over, looking at them, seeing if she could get the right answer, and when she did, moved on, and added a second hand, and then a hand for the week, and a hand for the month and year, and so on and so forth. And by the end of that, all those symptoms that I've described went away. And she went on to open a school that deals with other learning problems, Aerosmith School in Toronto, and now it's spreading throughout Canada and the United States. I want to talk now a bit more generally about the implications of neuroplasticity. Well, let's start off with psychiatry. For the last 30 or 40 years, those of us who do psychotherapy have been experiencing a kind of a rout whereby people stop thinking of psychotherapy in certain quarters as something serious on the basis of this reasoning, because it had nothing really to do with the brain, we were told. Well, we now know through brain scan studies that psychotherapy, psychoanalysis, and really any meaningful mental activity changes the brain. It changes the brain as radically as medication, in some respects more radically because it's more focal. When you're doing psychoanalysis with a person and you spot a conflict or something they've pushed away, and you bring it into consciousness and allow them to pay attention to it for the very first time, you're kind of like a microsurgeon going in right into the most important circuit. And you can do this in part because the way the brain works is, if I were to show you the letter A and you were all to look at it, a certain part of your brain would light up, a certain neural network would light up. Then if I were to ask you 3 days later to close your eyes and remember that A, virtually the same network. There'd be some alterations, but virtually the same network would light up. And we now know that mental exercise alone can actually change or restructure the wiring of the brain. An experiment by Alvaro Pasqualeoni took a group of people, divided them in two, and got both of them to learn a musical piece on a keyboard. The first group, basically they were taught a notation they'd never played before, and they sat and they practiced moving their fingers. The second group was taught the notation, heard the song once, and was told just to imagine playing it with their fingers. And when he was able to map their brains using transcranial magnetic stimulation, he found at the end of a week, both of them had very similar changes in the same areas. And they were both almost as good. And with 1 hour of actual practice, those who had done the mental rehearsal alone were as good as those who had done physical rehearsal. That may be one of the reasons that Glenn Gould, the Canadian pianist, towards the end of his career, actually used mostly mental practice. Now, when a person is having psychotherapy, we all now have studies that show the following therapies, and there may be others, I'm sure there will be, lead to significant brain changes in structural changes. There's been a study out of Germany that shows psychoanalytic psychotherapy does it. There have been studies here in Toronto that show cognitive therapy have changes in different parts of the brain than medication. Medication, by the way, at times can promote neuroplastic change. And we know that something called interpersonal therapy, which is a kind of a distant cousin of psychoanalytic psychotherapy, also does it. Now, this to me is very, very exciting because we also know that meditation actually changes parts of the brain as well. And drugs have been a very, very important part of the psychiatric armamentarium, and there are some conditions that absolutely require it at this point as far as I'm concerned, and I use medications. But drugs are a very blunt instrument because they bathe every cell in the body and they bathe every cell in the brain. And these kinds of thought-based interventions seem to be much more focal, and yet they also have effects which are very, very helpful on the hormone systems of the body and the stress of the body. So that is very exciting, and plasticity-based, thought-based interventions, I think, are going to be reshape how we approach mental illness. Culture rewires the brain. There have been many, many very problematic debates about nature and nurture over the years, and people have been divided into camps, and supposedly the nurture people were the biological people, and often it would be left-wing social scientists who would be arguing that what we think and what we do is the most influential. This has been an extremely non-productive debate, because the real question is always how much nature and how much nurture. But plasticity helps us to form a bridge between these two opposing camps. And many of people who have tried to root their concepts in biology and nature understood as that which abides in us or doesn't change, have become universalists when they think about human nature. And in many respects, I would say I was a universalist. One of the very interesting universalists was a man named Professor Nisbet. Nisbet basically was a follower of Piaget, and in many respects, and his great interest was logic and the development of logic. And he did some experiments because some people there was always a battle as to whether the teaching of logic and reason, which Aristotle said is the essence of being a human being in a way, should be taught. I mean, if it's the essence of a human being, you would think you can't really teach it. And Nisbet thought you couldn't teach it. So he set out to do a study to prove that you can't teach logic by trying to teach logic to people and reasoning. And to his surprise, he actually found you could teach it. And that was very distressing to a universalist who believed that certain things, a universalist psychologist who believed that there were certain windows of development that were inalterable everywhere. And as he tried to sort of inquire about this, he realized, first of all, that logic is very complicated, and their logic is not really, for instance, was not very big in the East. There are kinds of reasoning that are relatively recent discoveries having to do with statistics and probability that have to do with reason. And he started to realize maybe reason is something that is learned. And he re-examined some of the experiments were done to prove that we all sort of cognitively develop in the same way, and found that most of them were done by European or American scientists on their American college students, at which point he was challenged by an Eastern student that he was supervising to do the same experiments in both East and West. And what he found was that perception is very different. And I'm now talking about not opinion, but how people, for instance, would perceive a still life. And people by the West, I mean all of those people who in some way or other descend from the ancient Greeks, which is largely Europe and North and South America, etc., and basically have a number of shared assumptions, but not only that, shared perceptual ways of going about things. It turns out that Westerners are very, very good when they're looking at pictures, for instance, at finding the primary object. And if you give them and this is happening within seconds, it's unconscious, it's involuntary, it's what their perceptual system has been trained to do without them being aware of it. You ask them questions about the picture and the main object, they do very well, much better than Easterners. Easterners are very good in dealing with the relationships. And it turns out these things too are acquired unconsciously, and just as someone like Barbara Arrowsmith or the people who had learning disability problems were able to rewire their brains to perceive sounds better, so your culture is rewiring your brain, and then it's setting up circuits which also attach emotional valences to particular perceptions. And we're seeing these kinds of perceptual transformations in front of us just over time, as we note that younger people seem to have shorter attention spans. And even lecturers at Harvard need their PowerPoint to keep them on task. You know, at the famous Lincoln-Douglas debates, people were able to talk for, in long sentences and paragraphs for 4 hours, and everybody was able to listen. So these things are all being altered, and the media and technology do alter our brains. This is something Marshall McLuhan, right here at the University of Toronto, pioneered. And I used to think he was a kind of a, I don't know, a showboat who didn't really have much to say. But I've since learned when McLuhan said bizarre things like, pretty soon we'll be wearing our brains outside our heads and our nervous systems are in some way or other global, that this was a poetic way of saying that the electronic media operate by certain principles that are very similar to the principles that our nervous systems operate by, and that our nervous systems are plastically modified by the input that they are getting abroad. I want to conclude by answering a question I'd raised, which is, what is the fourth area that caused us to miss the fact that our brains are plastic? And the fourth area, the fourth culprit, is plasticity itself. I tried not to use metaphors in the book because the metaphor of the mechanized brain has turned out to be very problematic. But for this, I will use one metaphor, and that is that plasticity turns out to be like snow on a hill in winter. And because the snow is pliable or flexible, you can take many different paths down that hill if you want to go down it. Now, it's not an infinite number of paths. There are rocks on the hill and steep cliffs somewhere else, and there's a tree over here. But you'll find a hill, and if it was a pleasant run down, being human, you'll tend to favor a path down that hill that's pretty close to that path, all else being equal. And as you do that, precisely because the snow is pliable, or plastic, or changeable, you're going to develop tracks in that snow. And as you develop tracks, they will become ruts if you keep it up. And then it becomes very, very hard to get out of those ruts. So this is a metaphor that basically says the following. Plasticity, our perpetually plastic brains, can produce both plastic and rigid behaviors. And we look at our own rigidities and extrapolate backwards to our brains and then presume that therefore the thing that produced them must itself also be rigid. That is the mistake that we as individuals tend to make. And as we age, because we're told that our brains are not plastic, we tend not to try a lot of new things and keep doing the old things. And we get more and more entrenched and more persuaded that there's nothing much can be done. And you look around at the people who are a little bit older than you and they seem less flexible than you are, and you assume that there really isn't, a serious person doesn't really believe that once you hit adulthood it's possible to develop. An honest, mature person believes, as I once believed, that the sober, realistic thing is to accept that as you get past a certain age, you deteriorate. And talk of adult development is nothing but wishful thinking. And since as a psychiatrist and analyst I spend a lot of time debunking wishful thinking, I take it really seriously as something dangerous. And I wouldn't speak positively about plasticity if I didn't think it's true, because I am so wary of wishful thinking. But that much being said, fortunately I was wrong. And Adult development is much more possible. It's not as rapid as development in childhood, but nonetheless, it is very significant. And just as each of us, past a certain age, has had a very strong tendency to project from our rigid behaviors back to our brains, and therefore underestimate our own potential, I think that all humanity, for the last many hundreds of years, has been fooled by the plastic paradox and underestimated the remarkable potential of the human brain. Thank you very much.
Support Ontario's public television. Donate at tvo.org.